All right, we're going to talk about dependent sources, and I'm going to take you really in this sequence through a number of examples. In a moment, what we're looking at here is a voltage source here, and this is a voltage dependent voltage source. So really the value of this voltage source is actually 2 times Vx, and Vx is really the voltage across the 4K resistor. So the question here is, what is this current I? So how do we do this? Well, there could be a number of different ways of doing it, but what we're going to do is we're simply going to take a loop, okay? So we'll take this little loop here and we'll start to sum the voltages around that loop. All right, little convention I'm using is if I go up in voltage, I'm going to call it positive. If I go down in voltage, I'm going to call it negative. So here I am going round the loop. So I'm going from a minus to a plus, I'm going to call that a plus 12. I'm going from basically a minus to a plus, I'm going to call that a plus Vx. Come across this voltage source here, I'm going from a plus to a minus, so I'm going to call that a minus 2 times Vx. And then of course I've got the voltage drop across this resistor here. Well look, the current that we're defining in the circuit is I, going in this direction, and so that's a plus minus according to that defined current direction for I, and I'm going to say that is a minus then, because I'm dropping plus to minus, that is I times 1K, and all of that is really equal to 0. All right, so at the moment we've got a couple of unknowns in this really simple series circuit. We've got the I and we've got the Vx. Let's have a little look at this Vx, okay, and see if we can write it down in relation to that current I. So I'm going to just draw a little circuit on the side over here. So there we've got a resistor. I'm going to say this is my current I. This is that 4K resistor. And of course, the voltage that we're talking about is really that Vx. So look, if I wanted to talk about then the voltage across that resistor, I could say that voltage is what? I could say plus minus I flowing from a high to a low. I'll call that V across the 4K resistor. So that's V4K, right? That's a little subscript there. And I can simply say that V4K is really equal to what I times 4K. Well, we're actually defining Vx the other way around. So that's a plus minus. And so therefore, I4K would be equal to what? It would be equal to a minus, basically, Vx. So now what could I do here? Well, I could actually substitute for Vx, couldn't I? I could say that Vx is really equal to what? It is equal to a minus I times 4K. And I could put this into my equation up here, and I'd have everything in terms of I. So let's go ahead and do this. So we're going to take this guy and we're going to put it in here, and we're going to put it in here. And what do I have here? I'm going to have 12 plus, okay, I'll open up a little bracket here. What is that? That's a minus I 4K. That is the V of X. So that's a minus I times 4K. Close the bracket. Then I've got a minus, I've got 2 times that Vx, of course, which is a minus I times 4K, close the bracket, then a minus I times 1K, and all of that is equal to 0. So what I've got to do now is basically collect my terms together and really solve for I. All right, let's just collect our terms together. So what do I have here? I have 12. This is a minus 4K I, isn't it? And then that's a minus times a minus, so that's really what? A plus, 2 4s, that's a 8K times I. And then I've got a minus, what? I times 1K, and all of that's equal to 0. All right, so how many I's do I have here? Well, I have basically a plus 3K of them, don't I? So I've got 12 plus 3K I is equal to 0, and so therefore 12 is equal to a minus 3K I, and so I can really say what? The I is equal to a minus 12 divided by 3K, and of course that is equal to what? A minus 4 milliamps. Okay? That's our first example.